Hello everyone. So in this video we will talk about the periodic signals. Let's say you have a signal x of t and you shift this signal by time t, which is the capital T, some time instance. So this signal will be now x of t plus capital T. So now if x of t is equal to x of t plus t, which means that if the two signals are identical or equal, then the signal x of t is periodic with period t. What we mean by this? What I mean by periodic? Periodic simply means that a signal repeat itself at regular time intervals given by parameter t. So this is the periodic signal. Let's look at an example. Let's say you have this axis time, you have this y axis, and you have this signal which is this one, and this is the 0. So after some time t, the signal repeat itself. So at these 2 points the signal is same more or less. Okay, and then after the time t2 it obviously repeat itself again, and also on the other side the signal repeat itself minus t and then minus 2t. So this is a periodic signal. So it is essentially saying that x of t is equal to x of t plus t is equal to x of t plus 2t, and it goes on. So we can generalize this as x of t is equal to x of t plus m of t, where m is integer. It can take any value from minus infinity to infinity. So now we have this expression, and we say that t is the period after which the signal repeats itself. So if m is equal to 1, then this period t is called as fundamental period, which is the smallest time, first smallest time period after which the signal repeats itself. Fundamental period, and this is denoted by t of 0. So this is the smallest value at which signal repeats itself. So let's say if you have a signal x of t which is a constant signal. This is a constant signal because if you draw this signal for all the time instance, then this signal will always remain the same for each time instance. So this signal is periodic because if you look at any time instance, it is same. The value of this signal is the same as it was on the previous instance, but because the time is now here continuous and there exists a point, let's say this point, or maybe this point, or maybe this point. So for such a signal you can say that the period is undefined. The signal is periodic but the period is undefined. So you can say that x of t is periodic for any choice of t. So similarly, for discrete time signals, you have a signal x of n, and if this signal repeats itself after certain samples, then it is called a periodic signal with period n. But remember, a very important thing here is that n should be positive integer. And similarly, you can say that in this case the fundamental period is n of 0. So let's plot a periodic signal. You have n samples and this is x of n signal. So it is 1 here and 1 here. So it's 1 here and 1 here. So after this instance the signal is repeating itself. Okay. So after n sample you can see that this path is similar to this path and this path. So it is essentially saying that the signal is periodic with period n node. Let's look at an example. You have x of t, which is given as cos of t for t less than 0 and sine of t if t is greater than or equal to 0. So for t is less than 0 it is cos of t. The generic form of cos is cos of omega t, and omega here is equal to 1. So you can find the time period as t is equal to 2 pi over omega. So the time period is 2 pi. For t greater than or equal to 0 you have a sine of t. So generic form of sine is a sine of omega t. So omega is equal to 1 also here. So t is equal to 2 pi over omega. And then t is equal to 2 pi. In the next few lessons we will see that how this formula is derived. So now if you draw this signal, so on the negative side you have a cos of t which can be drawn in this way, and on the positive side you have sine of t which can be drawn as this. So it repeats itself after 2 pi period. If you combine this signal you have this signal So this signal is periodic here, but this signal is not periodic here. Here it is different. So we can say that this signal is not periodic. We can call this signal as a aperiodic signal due to discontinuity at t is equal to 0 that doesn't occur at any other point. The discontinuity which is present here, because here you have a value of 1 and then it suddenly here you have a value of 0. So this is all about the periodic and aperiodic signals. In the next video, we will talk about these signals in very detail in context of real and complex signals. So here we will just describe that why we want to study these periodic signals. Why? Because there are two very important reasons. These signals, the periodic signals, are predictable and they can be used to model real world phenomena. So you can say that the periodic signals are fundamental in communication systems and signal processing. This is why we want to study them and we want to understand that how these signals behave. Another important thing is that the periodic nature of the signals give us a very powerful analysis technique which is known as Fourier analysis. And the Fourier analysis is simply decomposition of signal into sinusoids. We will study this Fourier series as we will move ahead in this course. So this is it from my side and see you in the next video. Thank you.